So let's talk through our general steps for solving linear equations. So over here we have an overview of what steps we should follow to get to a final solution. So first thing we'll want to do is simplify both sides of the equation, and we'll talk about what to do with fractions in a future example and a way that we can make things easier there. But for this example that we see over here on the right hand side, no fractions to deal with, but we do have some simplifying to do. So first thing I'm going to do is I'm going to go ahead and distribute that 7n. I'm going to go ahead and distribute that -n. What I want to do is just get both sides of the equation completely simplified before I start moving things across that equal sign. All right, one more step of looking for like terms to combine. So let's see, we'll have 7x minus 17 on the left-hand side. And then on the right-hand side, we'll have a positive 4x with a negative 23. Okay, so that takes care of the first step of simplifying both sides of the equation, because now we're stuck. We don't have any more like terms that we can combine, nothing else to do there. Our next step is to collect all of the variable terms on one side of the equation using addition subtraction. And to kind of go with that is we'll have variable terms on one side of the equation, constant terms on the other side. So we're going to use addition subtraction to move. So like where I see I have 7x and 4x, I'm going to have those on one side of the equation. And there's two ways to do that. We can either subtract 7x from both sides or subtract 4x from both sides. Doesn't matter which one you do. A nice tip though is to move the smaller of the two, because that can help you avoid negative numbers, but you'd end up with the same answers in the end. But I'll go ahead and subtract 4x from both sides, so that we'll have a positive 3x minus 17 on the left-hand side, and then over here now we just have the negative 23. And then we now have everything with our variable on one side. Then the next step is to move our constants, and I want to get that negative 17 away from the 3x. So I'm going to add 17 to both sides. So we'll have 3x equals a negative 6. All right, so we have our variable on one side, constant on the other, which a constant is just a number. Then our next step is to make the coefficient of the variable term equal to 1. So the coefficient is the number out front. So what I'm looking at is I have a coefficient of 3, and I want to make that a 1. So to do that, what we're going to do is divide. I'm going to divide by a positive 3, and whatever we do to one side, we have to do to the other, and that will leave us with just a positive 1x, and then equals negative 6 divided by 3 is negative 2. And with that, we get to a final answer. Now, great thing to do is to check your solution. And to do that, what we would do is go ahead and plug in x equals negative 2 into the original form of the equation, which we can do that by hand, or if we want to real quick, just do that with a calculator. We can see, okay, 4 plus 7, and then in parentheses we would have negative 2 minus 3. That gets us a negative 31. And then the other side of the equation is a negative 17 minus, and then in parentheses 6 minus 4 times negative 2, and that's also negative 31. So just a real quick check to show that we did in fact get the same answers on both sides of the equation. Okay, so let's go through a few more examples here and then some special cases and just get lots of examples of solving these equations. All right, start by simplifying both sides of the equation. And if you want to with these, as a good review, if you want to pause the video and try these for yourself first and then check your answers, that's a great way to go about these, because hopefully this does feel like a bit of review, but it's good to check the steps as well and make sure all of the steps are going correctly here. Okay, distribute the 9n, distribute the negative n. combine like terms. So we'll have a negative 44 equals positive 4m minus 54. And with that, I'm going to subtract 4m from both sides. You know, in the same step, I could go ahead and add 44 to both sides. So on the left-hand side, that's going to leave me with a positive 5m equals, and then over here, negative 54 plus 44 is a negative 10. Divide both sides by 5. So we'll have m equals negative 2, and then we could go ahead and check our solutions to make sure that that works out. All right, with this one here, we don't have anything to simplify on the right-hand side of the equation, but we still want to simplify the left-hand side. So I'm going to have 5x minus 10 plus 4 equals the 8x minus 1. And that would be a 5x minus 6 equals 8x minus 1. And I'm going to go ahead and subtract 5x from both sides. Again, I'm moving that smaller one just to keep things positive. But again, doesn't matter which direction you go. All right, so that's going to be a negative 5, and this is going to be a 3x. Divide both sides by 3, and x is going to be a negative 5/3. Actually, this is going to be a good one. Let's go ahead and check the answer in the calculator with this, especially when we get an interesting fraction out. I might be a little tempted to check the answer here to make sure it does in fact all work out. So negative 5/3 minus 2, and then close parentheses plus 4. So we can see a negative 14.33, and then 8 times negative 5/3 minus 1. Okay, we are getting the same answer out, so I know for sure we did that right. Okay, let's do a few more examples here. So with this one, I'll just be combining like terms first. Let's see here. Okay, so we'll have a negative 2m minus 3 equals negative 6m plus 25. I'm going to go ahead and add 6m to both sides. And in the same step, I'll go ahead and add 3 to both sides. So that'll leave me with a positive 4m on one side of the equation and a 28 on the other side of the equation. Divide both sides by 4, so we're getting m equals 7. All right, last one here. Let's see, we're going to distribute that negative 8n. We'll distribute that negative 7n. So we'll have negative 7x minus 8x minus 16 equals 6 minus 7x minus 14. So negative 15x minus 16 equals negative 7x minus 8. Okay, I'm going to add 15x to both sides. And let's go ahead and add 8 to both sides at the same time. So on that left-hand side, we'll have a negative 8 equals negative 7x plus 15x will be a positive 8x. And I know some people like to have the variable on the left-hand side. You can always switch sides across the equal sign. Like if I wanted to rearrange this as 8x equals negative 8, totally fine. Just be careful that all of the pieces move left-hand side to right-hand side. But sometimes it's a format students kind of prefer, as having the variable on the left-hand side of the equation. All right, dividing both sides by 8, we'll have x equals negative 1. So those are some examples following those rules of simplify both sides. Then you're moving the pieces so you have the variable on one side, constant on the other. And then typically it's with division that you're creating that coefficient of positive 1 so that you can completely isolate your variable. And then you can use a calculator or by hand to check your answers to know for sure whether you got it. Okay, let's talk about some special cases. So let's say we go our routine that we were just following. So I'm going to distribute that 5n. I'm going to distribute that -2. So let's see, we have 10x minus 5 minus 5 equals 12x minus 2x minus 6. And let's see, that's going to be 10x minus 10 equals 10x minus 6. And I go my routine of subtract 10x from both sides. And when we do that, our variable is going to disappear. So if I simplify at this stage, I'm going to have -10 equals -6. And I no longer have a variable to solve for. So when this happens, there's two cases. It's either infinitely many solutions or no solutions. And it depends on the statement that comes out. So like we end up with -10 equals -6. That's false. Those two numbers are not equal to each other. So when it's false, what that leads us to as a final answer is that there are no solutions, which we can just write that out in words. Sometimes you'll see like brackets with a circle and a line through it. That means the empty set, like there are no solutions that fit this set. So if you end up with your variable kind of disappearing, or it's really canceling out is what's happening, and then you end up with a false statement, that means no solutions. Absolutely nothing for x will balance those two sides of the equation. The other scenario, which you can see with this one, let's say I distribute the -2n, distribute the -6n, so we have -2x minus 6 equals 4x minus 6x minus 6. So a -2x minus 6 equals -2x minus 6. And you can actually see it at this stage that those two sides are completely equal. But let's just get to that same stage of our variable kind of canceling out. So we can see we end up with -6 equals -6. So we no longer have anything to solve for, and we end up with a true statement. What that means is we have infinitely many solutions. In this case, means whatever we plug in for x, the two sides of the equation are going to balance out. Doesn't matter what we plug in, the two sides of the equation are going to be equal. So with that, we have infinitely many possibilities. We have whole numbers, positive, negative, fractions, anything will work. So those are the two cases you want to watch out for. If your variable cancels out, it's just a matter of is it true or a false statement you're ending up with, and that'll lead you to a final answer. Okay, this next piece that I want to cover just deals with fractions and decimals. Now with decimals, there's a few ways to go about it. You can multiply by 10 or 100 to kind of move the decimal around, or you can just keep it in decimal form. Either way is fine. So like with this one, something I could do is I go ahead and subtract 0.3x from both sides. That works. And that would just leave me with -0.45 on the left-hand side. And then what you could do is use a calculator to help out if you're not comfortable with decimals. So that would be a 0.9, ooh, that's off the screen a bit, 0.93. Minus 1.5, add 1.5 to both sides. So let's see, 1.5 take away 0.45 would be a 1.05 equals 0.93x. And then divide both sides by 0.93 to get a final answer. And with that, I will definitely use a calculator. So 1.05 divided by 0.93 for a 1.129. So you can do it that way. Another way is to recognize how many decimal places you need to move over to make things a whole number. And like some of these need to move 2 spots. So something I could have done was to multiply absolutely everything by 100, and that would have given me the equation, what, 30x minus 45 equals 123x minus 150, and then you'd have all whole numbers to work with, you're going to end up at the same exact answer. So either way works there. Okay, with fractions, something we want to do is to clear out the fractions, you want to multiply all of the terms by the least common denominator. So in this first case, we have a denominator of 5 and a denominator of 3. So if I'm thinking of the least common denominator, thinking of what's the smallest number that both of those multiply up to, in this case it would be a common denominator of 15. So what I'm going to do is multiply each term by 15, or really it's like I'm multiplying both sides of the equation by 15, and when I do that I would have 15 times that 2/5 plus 15 times t equals 15 times 5/3. And with the number that we chose, our denominator should cancel. So like here we would have 15 divided by 5, so those would cancel to leave me with a 3. So 3 times 2, I would have a 6 right there. Plus 15 times t is just 15t equals 15 times 5/3. Again, nice cancellation to leave us with a 5. So 5 times 5 is 25. And then we should end up with something that we can solve as we have been. So with this, I would subtract 6 from both sides. So I'd have 15t equals 19. Divide both sides by 15. So t equals 19/15. And that would be it. Let's do a few more examples with these. So, least common denominator, I'm looking at the 4, 2, and 3. And I'm thinking, what is the smallest number that all 3 of those values multiply up to? And that's going to be a 12. So, I'm going to multiply left-hand side of the equation by 12, right-hand side of the equation by 12. I'm just going to write this out. So we'd have 12 times 3/4 x plus 12 times 1/2 equals 12 times -11/3. And then we get our cancellations out. So 12 divided by 4 would leave us with a 3. So we have a 3 times 3, which is 9, with an x attached to it, plus 12 times 1/2, that would leave us with a 6, equals 12 divided by 3 would leave us with a 4. So 4 times -11, -44. Subtract 6 from both sides. Divide by 9. That would do it. All right, this last one, we can do the same thing, or what I wanted to show you with this one is that if you just have fraction equals fraction, you can do cross multiplication if you want to. It really accomplishes the same thing, but it's a nice little shortcut, but it only works if you have fraction equals fraction. There can't be anything adding or subtracting outside. So what we do is we keep our equal sign in the middle. It's just on one side of the equation. We go across denominator to numerator. So 4 times 7 will be on one side of the equation. On the other side of the equation, we'll have numerator times denominator, 5x times 9. So that'll give us a 28 equals 45x. Divide both sides by 45. And I'm trying to think if that reduces down at all, but I can't think of anything. But if you're ever unsure of fraction simplifying, you could check with the Desmos Scientific Calculator. So like 28 divided by 45. And there's this nice convert to fraction button over here. And like this, it stayed put. So that just confirms that, yep, there's nothing else to do. We would leave it just like that. So those are some special cases with decimals and fractions of what we should do to solve equations.